Well, so today's class, the new material we're starting to work on is program flow. So our schedule today will be as follows. I'm going to first of all start with, since most people passed milestone 3, I'm not going to do that. I think if you had not passed milestone 3, I think Sabrina discussed that in the tutorial, so we don't need to do that. Okay, so we'll start with a worked example for VP diagrams. Then we'll hopefully, we'll see how far we get there. We'll take up the homeworks for pointers. The route 1 that we did your homework for the last week, we'll take that up. We'll then review UML, the 4 types of flow. We'll talk about how to start to implement conditional flow in C, and we'll then work to correct the optics code. We'll continue correcting optics code after the break, and then you'll get a chance to retry milestone 3, retry milestone 4, or try milestone 5 if you've already passed 3 and 4. So those who are working on milestone 5 can do their first try on milestone 5. Okay, so this will be first try milestone 5 starting. And I hope that by next week, I hope this week everyone will be past milestone 3, or at least maybe 5 people, less than 5 people have not yet passed milestone 3. I hope by the end of this week. So we're moving forward. So let's get started. So please turn in your books to page 17. Page 17. Okay, page 17. And I'll shut down this one because I'm going to be using, not here, this one either. I will be trying to work through it together with you. So page 17 in your book, workbook. Okay, my VP diagram stuff. Okay, good. All right. Okay, so let's look at the question in section 6.1 that we're trying to do. Okay. This is a practical example, and I think I'm trying to make it sort of interesting in that it's designing a menu for a long-term care home. And we're just going to be doing the skeleton menu for the long-term care home and some of the basic things. So the problem statement you would likely receive. You have been hired to prepare a menu based on patient choices and diet restrictions for patients at an old age home. Residents may choose one portion of vegetables, one portion of meat for their evening meal. In addition, they may choose a double portion of a single item. And you've been given the following chart to start off with your programming, that basically they have like for vegetables, they have peas, carrots for that day. For meat, they have beef or mutton, and there's a portion size will be stored as well. But so they can have, for example, one portion of beef and one portion of one of these things. They have one beef, one peas and carrots, and they can have a double portion of one of these things. So based on these constraints and the choice of the residents, you're going to be writing a program that will ask the resident to choose their menu items and print the total number of portions the resident will receive. Okay? So for example, we will come up and we're not designing the user interface. That would be something different. But you can do that based on this. So C can be back. C is not a good language to use for user interface. You're better off to use a different language for user interface. C is good for the programming, but not for user interface. Okay, so for example, the person will choose a vegetable, and let's say they choose peas. They will then choose what meat they like, mutton. Then they'll choose which of them they want a double portion of. That would be vegetables. And then your program will calculate the total number of pieces or items that they get. So for example, vegetables, they get 12 peas plus 12 more peas, so they get 24 peas plus 1 mutton, so they should have 25 would be the portion on the thing. Generally, this would not be portion would probably not be what you'd be looking at. You'd be having calories here in a real situation. So you calculate how many calories each old age person is getting. Okay? Now, so first of all, we would then do a UML activity diagram to try to design our code. We would then write up commented code, and then we could then write an ANSI C code. You can see I've written the ANSI C code, the C code basically here in 6.1. So our situation now is that someone has already written a code and you want to understand it. And there's where we'll use VP diagrams to help us to understand how the code works that someone else has written. Because I think if you look at this code, it looks it's not that straightforward to understand, right? You've got choose vegetable, which returns a pointer. It requires 2 pointers. You have choose double portion, which is a double pointer. It takes a double pointer, and double pointers, and calculate items. So this person has this way written the code. Now we're trying to understand it. So if I'm trying to understand, I will then start on line 8, okay, in the main program as it starts to work. Okay, so main is initialized, so let's make a box for main. That would be my first step. I would then start to add the variable. So I've got 1, 2 containers, pea, carrot, beef, mutton, a couple of pointers, and 1 double pointer and 1 n item. So I start with my first variable. This guy is peas, and he starts with 12 calories, I don't know, okay. Next, and since I've got this thing, I'm likely going to want to just, why is it not locking? There should be the lock button, okay. No, it's not letting me lock, okay. Okay, unfortunately, okay. Let's try this guy, D. Okay, let's move him out of the way. Okay, peas and carrots. Moving on to line 10. I have 2 more variables to declare. Let's quickly throw them up. That is beef and mutton. And mutton. Okay, I've thrown them up. I then have 2 pointers, veggie and meat. Okay, let's get our pointers. I'll call him veggie and mutton. I next worry about my double pointer, which my double portion pointer. Okay, he's too big. He's not. Okay, good grief. Okay, I don't want you to jump to next line. Oh, good grief, it is still. Anyways, okay, let's make him bigger. Okay, and I don't want it capital. Okay, double P. Okay, now this I can design 2 ways. If I want to remember he's a double pointer, in other words, he's pointing to a pointer, I can add an extra dot if I like. I don't have to. This is optional. So some people would like to, some people don't. So some books you will see they add a double dot. But it's the same sort of container as these guys. It's just going to hold an address of a pointer rather than just an address of a variable. Okay, your choice. That's an optional thing. And the final one is an item. Okay, that brings us to the pointers are there. Okay, so this is what I've got in my main. Nothing's pointing at anything right now. Anything I got wrong here? Yeah, beef should only have 1 in it. So important to check first, make sure you haven't made any mistakes. Mutton has 2 pieces of mutton. Okay, carrots are the server is supposed to give you 6 carrots. Okay, all right. Okay, now let's look. Okay, the first thing is we're now calling a function called choose vegetable. Okay. So I'm going to have to make my new function. I'll call him choose Okay, let's see veg. I'll make them short so I don't overrun my area. Okay, see vegetable. And let's look at what he's got coming into him. He has 2 pointers prepared. So let's grab the 2 pointers. And 1 pointer is, we can look at his function definition. So choose vegetables, 1 pointer is, okay, he's receiving. So he's a pointer. He's prepared a pointer to point to peas. So to receive star peas. Okay, great. So he's got 1 pointer receiving to star peas. Okay, good. So I've got 1 pointer here that's going to be pointing to peas. He's got it, so it's his own name is peas. And another guy, his name is carrots. Okay. Both of those are going to be pointers, so obviously this is not the best way of doing my diagram if I'm going to do it this way, so I'll probably try to do something like this. Shift them into main so they're on top of each other so I can draw my pointers nicely. And maybe I'll put my mutton and pork down here too. Mutton, beef, and okay, and that's what he's got. Inside, he has a thing called star F. He makes his own pointer F. Oops, not that. I don't want this guy to go down. And he's got another pointer F. Okay, so you can see we're now on we're looking at line 21. Okay? So at line 21 it receives peas, it receives carrots. Okay, so we'll look at the call statement on line 13 now. Line 13 is a call. It gave the address of peas. So, put the address of peas into there, the pointer. We put the address of carrots. We receive the pointer, we receive the address of carrots. Okay, and so we give the option F print, F out, choose either peas or carrots. Enter P for peas and star for carrots, and it tells you what to enter. Okay, we get the choice of Johnny, quiet, thank you. Okay, so we try to get the choice. In other words, F, peas. So let's say the person has chosen peas. This is the example in which the user chooses peas. So I'm putting the address of peas into F. So in other words, now F now is now also pointing to there. Okay. And so that's what's happening in this function, and it's going to return F. F is going, so I'm returning F. You can see line 25 returns F. Okay, and F is then, so now the right side is veggie equals F. So veggie now equals F. So I can take where F was, veggie equals F, and choose vegetable is going to disappear now. It's finished. Okay, so that function is now finished. We're now moving to line 14. This function disappears. Bye-bye function, okay. But maybe I'll use them for something else. I'll just throw them down here. It'll be stuck in memory somewhere, but we don't access it. So he's chosen the veggie. We've got the choice. Now, the next one is meat. Choose meat, okay. See meat comes in. Oopsie, meat. Okay, and in this case, meat creates 2 pointers. One he calls beef. One he calls mutton. Okay, beef now points to beef. Mutton is, so when we call it, from the calling on line 14, the address of beef is put into beef, the address of mutton is put into mutton, so these guys point here. And let's assume now that the person, we print a message, we ask the person to choose beef or mutton, and the person chooses beef. There's no point in us writing code here to get the choice, because we're not going to be writing that in C. We will be writing, that will be a user interface. It will link to something in maybe Java or another language to do the user interface, okay? Or JavaScript if you like. Okay, so let's assume the person chose beef. So so now pointer F will now also we'll store that into F. So F equals beef. We place that into beef and we return F. F is now returned, and so meat equals the address of F. So where's my meat guy? Oh, meat was this guy. Sorry, he was not called mutton, he was meat. Oops. Meat is now equal to the address of F, which is, we shoot down to beef. Okay, so we've now set these guys up. Okay, let's move on to the next line. The user is asked to choose the double portion. So choose double portion. So I'm going to make this just short again. Choose double. So choose double, declare. Okay, let's get this out of the way and this out of the way because this other guy's disappeared now. Choose dub. Come on. Delete, delete, delete. Okay, I'll just leave the first few letters. And he prepares one pointer for veggie, one pointer for meat. Okay, so he's going to call one pointer. He's going to call one of his pointers veggie. He's going to call another of his pointers meat. And he's going to have that's all he's taking. So I go down to double portion, line 34. He creates a pointer to a pointer. Okay, these guys are all double pointers too, right? He's taking address of veggie into these double pointers. So maybe I want to make them double pointers so you're very clear that they're double pointers. We don't have to. And he also declares his own double pointer, which is going to be, his own double pointer is called D. Okay, so he's just a nice double pointer D. All right, so veggie is going to receive, he ends up pointing at, he takes the address of veggie, so he's now pointing way up here. Meat is taking the address of, M is, oh, he's not meat, he's just M, right? Oh, and M, not meat, he's called M, sorry. Yikes! In double port, M and V, sorry, I just used one letter for there. Okay, one letter, V. Okay, V is getting the address of veggie. M is getting the address of the meat, right? If I go back to the main program, he's handing him the address of meat. Okay, great. And so he's shooting way back here. And finally, I'm handing, okay, and so this is what we've got. And D we have not yet initialized. Okay, so in our program, we then drop down to see what does he choose on line 36. Choose a double portion of veggies or meat. Enter the first letter. So the person chooses a double portion of vegetables. Okay, so D is now going to equal V, which means D is going to point to the same place that V is pointing to. Okay, so he's going to shoot up here too. All right, and we're now going to return D. We're going to put D into the variable, into the double pointer. So I'm going to make this thing water. It's going to get so messy. Yikes. Whee! Okay, move over here, please. Double portion, please move over here. Okay, so when this thing returns, it has this number. It returns this address. In other words, veggie to the main program. Whee! Oh, sorry. Okay. And so the main program now has got somebody pointing to. So he's now pointing there. That's what's returned. And this program, this disappears. Yikes. Let's move you out because I'm going to probably want to use you again. And finally, oh, n item is not a pointer. It's a variable, right? It should be stuck a variable. Okay, n item just sits here. Okay, yeah, n item was a variable, not a pointer. Okay, all right. Finally, we now calculate n items. n items, we call a function called calc item. What does calc item get? Calc item gets, it prepares integers, no pointers. Okay, forget about the no pointer there, no pointer, no pointer. Just, okay, get rid of these pointers. It's not an integer it's getting. Let's get rid of these things. This, no, no, come on, I want my variable. Okay, so it gets, okay, I'm going to grab this nice 6. Okay, so what does it get? It's prepared 3 variables. So the first variable it's going to get is the number of vegetables. In other words, the main program on line 16 is giving what's held in the container held by veggie. In other words, 12. So it's going to get 12. It's going to throw 12 into here. All right. The next variable it's getting, we look at line 16. It says it's handing star meat. Huh, what did I do? How did I knock off my meat? I killed my pointer. Yikes. Okay, my meat was going to mutton, right? Where was meat going before? I can't remember. He returned beef. Oh, he's going to beef, sorry. How did I erase him? Yikes. Okay, so he will receive the value in beef, which is 1. Okay, so we'll 1 portion of meat. Okay. And so now, based on this, we're back into the program. It's going to now and what we want for the double. So double, veg, so it's receiving star star double, which means I have to dereference, 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 which is 12 again. I've now received 12. So these are the values that we have now in the variables in C item. C item now can calculate n item. It's got a new, it's got a variable inside called n items. I forgot him. Let's get him in here too. Sorry. Whoop. So, bother. Go up there, please. Thank you. So, n item is this other guy that now he gets it. The first thing he does is declare as a variable n item. He then initializes the variable with the value that n vegetable plus n meat plus nw. N vegetable plus n meat plus nw, it gives us 25. And finally, the value 25 is returned as items. Okay, he's items, sorry, items. Jake's items. Sorry. 25 is now returned to the calling program. Right? This gets returned way back over to here. And calculate item now disappears. So, in this way, so once it disappears, we can now print. The program would then say print how many items. Okay, so we print how many items, n item. This would be the VP diagram at the very end where everything is sort of pointing. Okay. So so this is an interesting one. So this coding gives an example of if you are using pointers rather than any conditional flow statements. But the main reason I want to show you this is so you can help to start to understand how pointers and variables work more. Okay? So it's not that we will want to program like this. You don't have to. But if we want to analyze somebody else's code, variables and pointers help us to analyze it very clearly, to understand what the code is doing, and we can think clearly through the code. All right. That's step 1 today. Okay, step 2, okay, so I'll get rid of this. Don't save. Okay, now, according to our flow, what we want to do next is, okay, so we want, not there. We're going to work, we're going to work on the root problem. and we should have, and we'll have our break whenever our time arrives at the right time. Okay, so let's start with taking up the homework, the root program that you were working on last week. So that will be page 47. Page 47 in your book. So we're on page 47 in your book. So we're looking at page 47. Okay, and we want to replace some information there. Okay, so let's. Okay, this is a square root problem from problem definition to solution. And we want to use, the goal is to use pointers, calling f_scanf from your function, rather than using my function, which uses pointers. Okay, so here's the code that we had that you were working on last week at your homework that you started with, was this piece of code, rvar.c. So you downloaded it, you were replacing the get float prompts and writing your own function to get both xs and xb with one call. You need to remember to include the prototype call definition, and you need to make use of f_scanf and fprintf and pointers to return. So here would be an example prototype, and so our goal now is just to modify this code. So let's start doing that. I'm going to grab where's my code? Oops. I did not. Okay, oops, I gotta grab it from there. I thought I had it already up. Okay, oh yes I do. Where's okay, I need to go to directory and cc. Sorry. SDC, okay. Okay, why is it switched? No, it switched open with something else. Sorry, yikes, wrong thing open up with. I don't want to use that editor. Edit with notepad, so I get a nice white background. Okay, so this is the variable one, and as you can see for our thing, when we're trying to modify the code, we have to get rid of John in live, get rid of these two xfloat prompts, and replace them with this for the prototype. Okay, so let's start to work on that now. So this is our initial code. I want to use this guy. Okay, so I'm getting rid of this. I remove the prototype for get float prompt, and I put in my own new prototype, void get xs xb double star xs, because I have to hand addresses, right? So I have to prepare pointers because I want to get two things back, so I need to give an address. So there's my prototype. It's going to receive two addresses where it wants to put the information. Okay, and I'm getting rid of these two guys. So to get rid of these two things, I'm just going to call my get xs xb, and I'm have to give it the address of xs, the address of xb. Okay, so these two parts this is quite straightforward. We just have to get two addresses, the address of xs, xb. Now we have the more challenge, which is to write our function definition. So we have the prototype, we have the call, now we need a function definition. Let's just stick it in here. Okay, so we can still see the top part. Okay. See with okay. I'll copy my prototype down. Maybe I think I'll do my prototype just in S, make it easier for me just to write one letter. Okay. All right, S and B. Okay. I'll call them just by one letter in my function this time. Okay, so I got S, X, B, and I want to get them both. So I first of all need to put a message, fprintf. I'm sending it to the monitor, standard out. Okay, and I'll probably give the prompt I want to get, input value too small for the root. Okay, so I can put that as my first message. And then I can put, then I F scan F. I want to get from the standard in, which is your keyboard. And I need to give an address. I want, not percent. It's a double, so it's percent LF. And then what I'm going to get S, right? Because S is already the address to place it into. So I want to place it in the container S. Next, maybe I'll do another one, F print F, standard out, input value too big for the root. Okay, there's my second, and F scan F, standard in from the monitor, percent LF, and I'm going to get B, the big number that's too big. And that's it. That's the end of my function definition. All right. So this is one way of doing it. Okay, let's edit comment all, auto comment, comment, single line comment. Okay, sorry, no, I don't want a single. I'll just single line comment the inside. That'll make it simpler. Okay. Edit, comment, single line comment. Okay, I now comment out. Another way to do this would be to do this with it. F, print F, standard out, input values too small and too big, separated by a comma. Okay. Something's missing, something's wrong. Why is it being so? It's not changing color. Why? What am I missing? Something is not right. I don't know why it's not bothered changing color. You should change color. And then it would be F scan F, standard in. Then we have to write down percent LF, comma percent LF, and then the values S and B. Okay, in this case, I don't know why, I'm not quite sure what I've done wrong. I've got something wrong here because it's not changing color, so I know there's something not, okay. Actually, it looks okay, yeah, I guess it's okay, yeah, there's nothing here, it should be okay. All right, so, no, if you do it this way, and the person puts a space and not a comma, the program will crash. Like you could write it this way, or you could write separated by a space. Okay, this will work too, but the person now has to put a space between the two numbers. Anything else, the program will not run. Okay, so this way is more safer because you're only inputting one thing at a time. This way, you can put in both things, but you have to tell them how to separate. I could also, I could say separated by a semicolon. Okay, this would work as long as the person puts in a semicolon. I could have them put them in separated by a colon. It would still work, but I have to make sure it's separated by a colon. If the person does not do it exactly in this format, for example, in this case, they would have to type, on the user would have to enter in like 45.3 colon 1.23. If they do anything else between them, the program will not run. Okay, so you'd have to be very careful of doing this sort of an input. Okay, so that would be how we could modify this program. That should complete this and this. Okay, so file, save as, I'll save it as r.c, just simple r.c, okay? And let's try to compile it. Back to my SDBA, right? NCC, open. All right, we've got our compile, okay. GCC minus C minus wall minus G r.c, GCC minus O r.exe r.o. You don't need stand library anymore. And now R. Okay, input values too big and too small separated by a colon. Okay, so let's say 43.52 colon 1.24. Okay, so y of 22 points. Okay, so it's done the calculation. This may not be the best. Okay, so it's done the calculation now at 22 thing. Okay, so actually I made a mess. Big too small. That's big and small. That's wrong. Even input wrong. Okay, so 1 colon 2. Okay, let's do reasonable. Okay, all right, 1.5, calculate 0.25. Okay, so we do not check for any errors here, as you can see. Okay, all right, that brings us to, okay, so that gives it, okay, now let's move on to our, so let's look now, continuing on. Okay, so we made our code, we modified it. And this would be our modified code. Basically, this is the way I did it this time. XSSB, nice and short. Okay, SMB, that's okay. So this would be all the complete code for that program. Without the, and mean and equation don't change. We never touch those. Okay. Okay, then we need to compile and run the code. So we don't need johninlive.o because we're not using anything from it. We don't have it included, so we don't add it on the end. For this one we would use, so the other earlier one we needed to have johninlive. This time we don't when we link. Okay, and now let's analyze the code. I want BP diagrams again. Okay, 2 lines, information for the human reader. We're familiar with that. Info preprocessor, the function prototype that is not in the file. Function prototypes that are in the file. Okay, and then main starts. I declare 4 variable containers, XS, SB, X, and Y. I then call get XSSB. I give it the address of XS, and XSB has prepared 2 pointers to hold them. So the address of XS is put into pointer S. The address of the variable XB is put into the pointer B. So I've got my 2 pointers. We then call, we want to get these numbers. Okay, so we first fprintf. When we call fprintf, what do we have? It has 2 pointers, right? The first pointer is pointing where do I want to get the information from. The second pointer is pointing to what do I want to print out. Okay, so it doesn't pass this value, this thing. It just puts a pointer to that, what I want to print out, and I print that on the screen. So the screen, I get this nice thing printed. I then call fscanf. It basically has 3 things: the pointer to where I want to write it, in other words, where I want to get it from, i.e. the keyboard, a pointer to what it looks like, %lf, okay, and finally a pointer to the memory location that I want to get it from. In other words, it's taking the pointer to the same place that S is pointing to. So now I've got, you can see I got an S pointing there, scanf is pointing to this guy, and so when I type in 1 on the computer screen, 1 is then stored into main. So the 1 is grabbed from here, and moved and pushed into this address. fprintf is called again, this time putting again. Monitor is in one spot. The other pointer goes to what I want to say. I call fscanf again to get the information. fscanf, get it from the keyboard. You're expecting to get something formatted as a double, and you want to put it back, and the B address is where you want to put it back into, so it's received the address of B, and so it's also pointing to now XB, so it grabs 0. When the person types in 2, it stores 0.2 in the memory, and returns. cmean is then called. Here's cmean down here. It's called. It's got 1, 2. It runs and it returns. It adds them together. 1 plus 2 divides by 2, returns what's in the middle, which is 1.5, and sticks it in. Okay? So you can basically see how we're doing it. You see how it does. 1 plus 2. Okay, 1 plus 2 is 3. Divided by 2, 0.15. So it's basically not touching this mantissa right now, right? So it's just adding them and it's keeping everything in the first decimal place. Okay, then we call the equation. It receives the value of x and a value of 2 because I want to say I'm doing the square root. Okay, I'm fixing at the square root right now. So x2, so it's x squared minus p. Calculate static, it's 0.25. And when it returns 0.25 to the main program. Okay, and finally we call print again, and print basically prints out the final answer. So that's how the code actually works when we analyze it. So we should be time for break. I think, we're a little bit early. We're 2 minutes early. Okay, great. Okay, so we will break now for 10 minutes, and we'll come back to you to the next section, okay? We'll break for 10 minutes, okay? I'll let you have your computer screens back until about 2 minutes before. Okay. If you need the TAs to check your homework, they can check your homework now. I'm writing your stamp, signing your book, you completed the homework, okay? All right, so that's all if you want to do that. Okay, guys, let's come back. Okay, Eisenberg, back to your spot. Okay, guys, anybody we're missing outside? All right. Okay. All right, so we're now going to review UML. And we're going to start with how do we implement conditions in C. And we'll try to go through our first problem, will be the optics one. Okay, so let's get started. Okay, move to our next thing. Okay, all right, let's review the UML. Okay, we have three main constructs. Actually, four main constructs, because parallel is also, that's a later course. This course will cover three. The first construct for your UML was the linear one, right? Which we just go straight down, do some work, do a little bit more work, and continue on to the end of the program. Okay. The next construct, so this will be sequence. Okay, we do something, continue on, do something else. Each line executes once, and basically every program we've done so far is done this way. We have not, this is everything we've done so far is sequential programming. Now, we're going to be moving to our new example, which will be, remember, decision. Based on the data, only one part of the code is actually run. Okay? So, for example, based on data, only the right side is actually run. And the left side is run, the right side is not. So we have a split and we merge. This would be a conditional, decision-based conditional flow. Okay, we're clear on that, I think. Okay, loops, you saw that guy, it does something, zips along, tests a condition. This is a loop that's going to run 2 times. It runs a second time, goes around, does the work, comes by, checks. Oh, it's already run twice. Okay, I'm finished. And then it continues on to whatever's going to be next. Okay, so this would be our looping. Okay, repetition. Each function starts to run, each line executed many times. So these are the 3 UML structures that we have. Then you can see the 3 different types of flow moving through. And we combine these things just to make our program to build some sort of a program. Now, okay, program flow, sequence, decision, repetition. Why do we need? Okay, why do we need sequence? Sequence carries out tasks, it does calculations, it calls functions, right? Here we're seeing a calling a function. We're initializing something. We're doing something to print. Why do we need decision? Okay, let's say root finding. We've already done that as an example UML, right? If b squared minus 4ac is less than 0, okay, d should be equal to 4ac minus b squared. Or otherwise we need to do the opposite. D equals b squared minus 4ac, and this way will be imaginary. This way will be, and then do the square root before taking the square root. And we're going to see another example in our optics code where we're going to need decisions. And we'll try to explain, we'll work on that, and that will motivate us for using decisions. So this is why we would need decisions. Okay? All right. Why do we need repetition? Well, for the optics, nobody is a single lens system. You need to do multiple lenses. For following objects, we'd like a loop to read all the data from a file and calculate without restarting the program. For the root finder, we have to keep narrowing in on the root automatically, not the user keeping to guess and slowly entering in himself. This also needs repetition. Okay, so given that we need these things, how do we code? Okay, how do we code decision? For example, this little construct, I have 3 variables. I have 3 A, B, and I want to set C. I want C to be what is this code doing? It's selecting the bigger number, right? If A is greater than B, C will be equal to A. Otherwise, C will be equal to B. I've selected the larger number. So I'm selecting a number in this code. Okay, so here would be the simple C code to do that. I have my comments. What it's doing is conditional. Okay, integer main void, double A equals 5, B equals 3, and C, I declared my 3 variables. If A is bigger than B, these brackets, then these brackets, what to do if A is greater than B, I put the value of A into the container C, semicolon ends the line. The if condition is ended with this. Then the else condition starts. If that's not true, then it will run this part. Again, this curly bracket, put the value of B into C, semicolon, curly bracket. Okay? So that would be how we would decode a simple decision. Okay. So let's analyze the code. In main VP diagrams, okay, I declare my 3 variable containers, A, container A, container B, and container C. And I initialize them with 5 and 3. I then start my code. If A is greater than B, we check. I'm doing a conditional check. Is A greater than B? It is. So I run this part of the code, put the value of A into C, and then jump down to the end. So this part of code does not get run. So questions I might now want to ask is, what is the decision format? What conditions can we test? How do we handle multiple simultaneous conditions? And what about multiple paths? Okay, there's a whole bunch of questions we need to ask ourselves now. So I've given you a basic example, but now let's start to work through the details. Questions? Any questions? Up to here okay? Okay, good. All right, here's the format. If condition in terms of brackets, open this curly brackets, close this curly brackets, and a whole bunch of things to do if it's true. If it's true, do these things. If it's not true, there's the else, bracket, bracket. These are the things to do if it's not true. So I have, what do I want to do if it's true? What do I want to do if it's not true? So the important point here is that the condition must be a true-false question. Okay? Any condition in programming you must be able to answer true or false. You can't answer maybe. Okay? It's got to be true or false in this standard programming. Okay. Oh, question? Yes, you have a question? You're okay? Guys okay? Anybody else okay? Tom? Any questions? No? Nobody asked? Rebecca? You okay? Maybe. Okay, good answer. I like it. All right. Okay, first condition. I can check if A is equal to B. Now note, when you're checking if something is equal, you have to use 2 equal signs, not 1. Okay? 1 equal sign means put the value on the right into the container on the value of left, into the container on the left. So take the value, if I have 1 equal sign, it means take the value out of container A, B, and place it into container into container A. If I want to check if what's in container A is equal to the contents of container B, I have to put 2 equal signs together. This is a very common mistake. Okay? That's testing if something's equal. Okay, and there's my point. A singles equals means to put the value on the right into the container on the left. Example A equals B, we'll put the value in B into container A. All right, next. What is this test? Okay, Johnny, what is this to test? Not equal to, yes. So if the value in container B is not equal to the value in container A, we'll get a true value. Okay, that's going to give us true. So these are basically opposites, right? I can check if the value in container A is less than the value in container B. Okay? If that can be true. Or I could test, is the value in container B greater than or equal to the value in container A? Okay? Slightly different, okay? So that means greater than or equal to, okay, A less than. Or I can test if the value in container A is greater than container B, i.e. B is less than or, okay, actually that's not quite exactly. I don't know if that's a mistake there. So these are all different conditions that I can test. 4 different conditions I can test. Okay, all right. This would be for these conditions. Now, how do I handle multiple conditions? Okay, double ampersand means and. Okay. Okay, English note. This symbol is called an ampersand symbol. This symbol is called a pipe symbol. So on your keyboard, the pipe symbol is just above the enter key, and you have to use, to get that symbol, you have to type shift and then the key just between the enter and the backspace key. That is the key for a pipe symbol. The ampersand symbol is you need to press shift and the 7. That will get you the ampersand on a keyboard, English keyboard, and Chinese keyboard as well. Okay? So, and finally, this guy is called an exclamation mark. The exclamation mark is located, where is it all located anywhere? Exclamation mark is, shift 1. Shift 1, exclamation mark. So, what do these mean? This guy means and. Okay? By the way, what do we use a single ampersand for, Felix? A single ampersand means what? If I put the single ampersand,
We take the address.
yes, the address of a variable. So 1 ampersand is the address of a variable. Okay? 2 ampersands is used for and. 2 things together. If you put, okay? All right. If I want to do or, I do 2 pipes. So 2 pipes is or. It's nice, very efficient, right? For and, I only have to do 2 characters. Or is just 2. And not is 1, just not. So I can negate anything by just putting this in front of it, the exclamation mark. So these are so for example, if A is less than B and B is less than C, that's a condition. So it checks, is A less than B, true or false? If it's true, it will then check if B is less than C. If B is less than C, true and true, okay. Of course, if it first finds A is less than B, it won't bother checking the rest because it already knows something's false. Okay? So once one thing is false, it won't check anything else. Okay. Or, okay, would be written like this. A less than B or pipe, B less than C. Okay? Then it will execute. That would be true. And here's the not. If not, A less than B. Okay? Now, obviously that means you could flip it the other way around and say A greater than or equal to B and not use the not sign, right? Okay, so A greater than or equal to B, you could test the same condition this way. So probably you would not want to use a not there. For good style, you should probably write A greater than or equal to B. Okay, all right. What about multiple paths? Okay. In other words, I want to go in multiple different directions based on something. Okay, we've talked about this. In other words, you know that in UML you cannot write this. Right? This is not valid UML because each decision can only be true, false. Okay? In C programming. Okay? I'm not talking about in AI. You try to do other things. So AI models, you might have a symbol with multiple x's. Okay? But in standard programming, when you have to actually program it, you have to go one way or the other of the program. Okay? More abstraction, you might have more like true, false, I don't care. Okay? Would be a 3-level system. But we are basically working on binary systems. Okay? You can't do this. Okay? Alright, so here's how we can do multiple paths in C. So for example, check status. So I've got a check status. If the person is married, their value is no value. They have no value. If the person is single, their value is their initial value times 2. Okay, you can see here we split here, join. Single, we split. Next, check the next condition. If they're single, we multiply the value by 2, and then we merge and go back. If they're not married, not single, if they are divorced, we then check again. Are they divorced? Okay, if they're divorced, we take this one, we then join, come back, back, back. And finally, if none of these are true, they're not married, they're not single, they're divorced, we multiply this value by the previous value by 0.9 and come back. So you can see, divorced, these guys have to match. These two have to match. These two have to match, the merge and the split. So you can see these guys, this split is the first one that merges, okay? So you can see this would be how you would write it in C. If status equals marriage, then do the calculation. Else, if status equals single, do this. Else, in other words, if this is not true, come to the next level. If status equals divorce, this. Else, in other words, none of these are true, multiply the value by 0.9. Okay, this is one way of handling multiple paths. So, in summary, would be if condition 1, statement to do. Else, in other words, condition 1 is false, check condition 2. And if both are not true, do this. Okay, so only one of these will be executed each time. Another way of handling multiple, C gives another way of handling, which we're not going to talk about in this class, but it's a switch condition. It can be very clear. If case result A, execute if match. Case result B, execute if there's a match. And then if there's no matches, execute. Alright, so each of them you put case and what, like case married, so in this case it would be, it is only limited usage and you don't need to ever use it. But you should know it if you see in other people's code, okay? This only can be used in special cases. People use it in special cases, but it's not as general as, this can be used everywhere. This can be used with integers, okay? Alright, so, but you need to know it, okay, great. Okay, so there's my example of how I would write that, this one in doing this. Switch case married, case single, case divorced, default. That would be how I write it using switch statements. Okay. So we're now going to try to apply this error to the optics equation. So let's move to, so we will now move to, where are we? Okay. I'm gonna have to show this slide. I think this slide is, where's my slide gone? Okay, there's an error in the optics code, and we're going to try to fix that. Okay, so I'm going to close this guy right now, and we will show, please. Okay, so we're, wrong code, wrong one, sorry. Okay, okay, let's just a sec. I'm back to here now. Okay, you're going to go to section optic, section 7.1, page 38. Section 7.1, page 38, please. Section 7.1, page 38. Okay. All right, so I want you to, so we're going there. Please. Okay, looking at our main thing, I'm going to free up your computer screens in a second. I want you to come down here to, we've worked on this. We've made a coordinate system. We made it into pointers. Okay. All right. So this code right here that we just did, this code, 0pointer.c, which is right here, o.pointer.c. This code that we wrote, okay, that we worked through, I want you to download it. Download this code to your own computer. All right, we're going to download this code. We're going to look at it and see what is wrong with the code, okay? You're going to download it. Try to go number A. Try to calculate these numbers, okay? So OX, OH, LX, LF. OX, OH, LX, LF, enter them into the code twice and see what numbers they give and think about it. What's the problem? I want you to think about what's the problem with this code. Why is it? And yeah, so this you're going to download, and I'll move this to here so we can see what you're so you see where you're getting it from the main thing, and I should. Okay, so I'm going to free up your computers right now. Let you guys have your computers. Please download from C that code. So you'll see where you're downloading. Okay. So, okay, guys, you help them to download. Make sure they can download correctly. Okay. Okay. So we're downloading this guy right now. See? All right, now copy it into the notepad. Okay, copy the notepad. Okay. Okay, I guess we might have come back. Okay, let's come back. We'll walk through it a little bit. I think hopefully you've had a chance to see some of the problem with it. Okay, let's start looking through the code. Okay. Our optical ray tracing simulation. Okay. Hey guys. Okay. When the program fails. So first of all, so you've completed the length formula, which you learned in high school. Like 1 over O plus 1 over I equals 1 over F, you learned in Gauss. There's always some problems with weight, but actually, that formula may or may not. Okay, so let's look. When does it fail? Okay, there's our first case. We're looking here, okay? What happens? Okay, I put my object is located at 0. He has a height of 1. I place my lens at a position 5, and it's got a focal length of 5. Okay? I type into my program, and what does it give me out? You probably saw that. O was 5, I was inf, xi was inf, hi was inf. So what does this mean? Okay? It can't, okay, where is this guy located? This guy is located at the focal point, right? If I place something at a focal point of the lens, what does it do? Basically, my lenses come out, and my image will be at infinity, right? That's basically what we're saying. So the image is at infinity. This is correct, right? If I'm at a focal point, if I'm at the focal point of a lens, then my image will be at infinity, right? I'm at the focal point. Or if I've got a lens and I look at the sun and I put a magnifying glass, I can then magnify the sunlight onto a point. If my surface is at the point and my ant is at the point, I can magnify the sunglass, hit my ant, and burn it, right? Don't know if you guys like to burn ants. I don't know. My daughter likes to burn ants. Okay? But what happens if this case, okay? Where's I've got the same lens. He's at position 5. He has a focal length of 5. And my object is placed at position 10. So my object is over here. Now what happens? I do I get -5, 2.5, 7.5, and 0.5, and it says my image is going to be stuck here. He's going to be half as big. He's going to be at position 7.5. Now, look at these two cases. This person is 5 units on the right side. This person is 5 units on the left side. One of the answers is wrong, right? Because these are mirror image cases. So in one case, the program is giving the wrong answer. Right? Okay, they can't both be right. Both of the people are 5 away from the lens. One is on the left-hand side, one is on the right-hand side. Okay? So both cannot be true. One of these cases is wrong. So the program is doing the calculation wrong in one case. So what does this tell me I have to do? First of all, I have to detect which case is wrong. Looking at the two cases, drawing the picture is very important to understand what is wrong. If you don't draw the picture, how are you going to tell what is wrong? Right? So from lens formula and optics, we can see that basically the one on the bottom case is wrong. In other words, in the case that we are on the right side of the lens, the answer is wrong. So now, please try to write a UML diagram to deal with both cases. How do we need to change? What's the if condition we have to make? What is the calculation we have to do on the left wing and the right wing? So look at this in your textbook, in your workbook, draw the UML. Okay, think about this problem. Try to draw the UML. Okay, and then once we draw the UML, we will continue. Okay, so where are we? So basically, if they were the same, I should have this basically, right? It should look like this. This is the correct. So if the person's here, I first need to know what my correct solution should look like. So we know the second case is wrong. So what the correct solution is, I should also get int. My computer program should also divide by 0 and crash. Okay? So in both cases, I should crash. Okay. All right, so we'll work a little bit on UMLs, and again, the TAs will wander around and try to help you. I'll try to help you as you do your UML, and you need to think about this. If you don't understand something, ask Sabrina, ask Johnny. They can help you to understand what's going on here, why the optics equations are not functioning. This is like, I think this is physics lab, right? You guys still have the physics lab, this lab, right, I think. Optics lab, 1, or, okay, maybe you don't. No, C, Bingzu do. Bingzu has this, okay, not an Azu, but not you guys. All right, forget this. Okay, sorry. This is Bingzu and other Zu. I think Azu and Czu, Bingzu. I'm not sure you guys do or not. Okay. Okay. Okay, hi, okay. Yeah, you learn case 1, not case 2. Because you always assume it's on the left side. That's the problem. Junior high school always assumes it's on the left-hand side. And you always assume light goes this direction. In junior high school, they never have light going from the right to left. It's always from left to right, no equation. So when lights come in the opposite direction, it doesn't, we usually the same equation. Okay. So you're in 7.1b. 7.1b we're working on right now. Okay, so, okay, okay, for your use, you can see that there's your old UML. There's the old UML. So how are we going to change this equation to be correct? That's basically what we're trying to do. When O is less than 0, it's calculated correctly. Okay, what about, okay, I is wrong, okay? When the object is to the right of the lens. How do we solve this problem right in here? This is the guide. So this is going to have to be replaced by a conditional. Okay, so you can need to think about that. How do we replace it with a conditional? Okay. Okay, we'll break for about 5 minutes. Okay, you can break for about 5 minutes, and when we come back, we'll try to make sure you understand what's going on. Okay, let's come back, guys. Let's continue on. Okay, we're going to try to continue on. Koilai ba. Okay. All right, let's get started our third hour. Okay, so we'll go finish the optics code and then we'll probably do the milestone retry. Before we start, okay, let's get started, guys. Okay, so we talked about this is the wrong calculation. So now we have to think about this. This is the formula that we're actually using. Okay? The crucial thing here is that the image location should be at infinity, no matter where we are. Where did the calculation go wrong? We see that I is calculated wrong, so therefore xi and hi are also wrong. Okay, where does the wrong error start? Okay, so 2.5 is wrong, 7.5 is wrong, and 0.5 is wrong. Infinity is correct. It should both be at infinity. This guy should be minus infinity, and basically minus infinity or whatever. Okay? So we have because we have no image. Alright, so let's move down and look at what's wrong, what's happening. Okay, we look at the code. We see that, let's try it on the negative side. When O and F are, okay, O, F, both positive, okay, I is at infinity, F times O, O minus F, But when we have a negative number, i.e. we're on the right side and not the left side, both O times F is wrong. O minus F is also wrong. Both these numbers are wrong if the object is on the right side. So this is object on the left side. If object is on the right side, O comes out as minus 5. Our program calculates O as minus 5. And then F times O is minus 25 and not regular 25. O minus F is not 0, it's minus 10. So clearly, we need to modify the equation, right? Because the calculation is wrong and O minus F is wrong when O is less than 0. Okay, so let's look at this new equation. Now, I can see what's the problem. F times O, it should be positive 25. Okay, so all I have to do is I want that to be positive, I put a minus sign here. O minus F should then become O plus F. That will give me 0, right? So if I change this to a minus sign and O plus F, so now it's correct if we're on the right hand side, but it's going to be wrong if I'm on the left hand side. So the equation is different for me to use on the right hand side and on the left hand side of the lens. Okay? So now I can do my UML diagram. So when O is less than 0, I'm going to use this equation. That's the standard one. 1 over I plus 1 over O equals 1 over F that you learned in high school. But on the other hand though, this is the one used in high school. But when O is less than 0, we have to make use of this guy. So in other words, if we're on this side, we need to use this one. If we're on this side, we need to use this equation. So we need to, depending on our side, gives us the equation to use. That means in our C code, we're going to have to modify our UML. So now I have this UML. No longer do I have just one equation, I have to have two equations. If O is greater than 0, use this equation. If O is less than 0, use this equation. Okay? So when O is greater than 0, we go to the right if we calculate O greater than 0 in the equation. But if O is less than or equal to 0, let's just execute the left side. Fair enough? There's our UML. Now we can, if we want to move that to C code, okay, how do we express this UML in C code? Very simple. If O is greater than 0, use O times F, O minus F. Else, use I equals minus O times F divided by O minus F. So I now have putting an if statement. So if we are modifying our original code, okay, I'm going to have to use an if-else structure here. What's my time? Better check my time, make sure I got the time. Okay, so here, where is the change going to be? It's right in equation lens, right? I no longer have one equation, I've got an if-else. So if O is greater than 0 and else, okay, let's look at modifying our code. All right, let's go to our, if I got to get my code, our code modification is basically this. It's right in the equation lens. It's only down here our modification, right? Nothing has to be done in the main code, only in equation lens. If O is greater than 0, use this equation. Otherwise, use the equation with the minus sign divided by this and this with the thing and then return I. So there's our modified code. All we have to do is add an additional condition. So this is basically the way I would program. When I first wrote the program, I didn't realize this, but then I had to make my modification. Okay, and we can just basically run the code, and you'll see it basically runs okay. And let's do the analysis again. Information for humans, preprocessor information, function prototype, which one are we using? That's for probably fscanf and fprintf. These are all the functions now in this file. The one we just modified is just this one. The other ones we're not changing. The main we're not changing. Our main function. Okay, just as before, all our variables. We first call get opt to get these guys, XO and H, the height of the object and its position, then the position of the lens and its focal length. We calculate O. We calculate the equation of the lens. All right. We're calling the equation of lens. We hand these things to equation of lens. Note this is a minus, so it means O is on the right hand side. The focal length is still the same. Okay. It creates a variable I. It checks. Is O greater than 0? No, it is not. So we need to go to the else statement. And once we jump down to the else statement, we then execute the else statement and put I is now minus 0.1, in other words, minus 10. Okay? And we then return I. Okay? Getting us our final returning I. We have the image position, etc. Okay? And then the probe just continues on calculating. The magnification is calculated, CI is calculated, and finally we print out this. In this condition where O is minus 10, I 10, XI, H. Okay? And that will be the end of our code. All right, so that's our example for O. So now I'm going to give you the, we'll hand out that we can now, next spend 30 minutes on the milestone, retry. You can cut internet for them. Caution, John. In future, do not leave them like this. So if anybody comes walking around, just look at the milestone we put a test. Don't just leave them sitting like this on my desk.
Okay.
Because the milestone is obvious. Anybody wants to look at it.
Okay.
Okay.
Okay. Okay.
Okay, that's not.
Okay.
Okay, good. All right. So. So make sure you know which one you're trying. Alan, are you here today? Alan? No, okay, good. Okay, sorry. Yeah.
What is this one?
What means?
What is what cause the program crash?
What does crash mean? Crash means not work.
Oh,
What input? Example? Give an example of an input.
also they need to take examples. Oh, what input would make this crash? Only
Yeah,
this.
crash. Program crash. Doesn't run properly.
So they need to write in the paper.
Yeah, yeah, just like you guys did last year. Yeah, I think so. Yeah, or maybe not last year, but if you had passed this milestone, you would have written it. Yeah.
I already forget it.
Okay, fair enough. No problem. Maybe if you did this version of the milestone, I should say. Okay. What the heck happened? No. Finish, okay.
Finish.
Does it look right? If it looks right, then you can take it or look at it. Okay. Okay, I can't look. Please can you finish it? We aren't on the mark here now. Yeah.
Yours is Louis finish.
Okay. No. Okay. hyperverse, just with the discuss that
Okay.
We have about 10 more minutes. 10 more minutes. I have to then jump to go up and pay that dollar. Okay. Okay. I'll check. I'll check later. Okay. Cool. Yeah, okay. Right. Okay, hi, okay. No. No talking, please. This is you can't use that function. Because they had there was another using our model system, visual system mostly. Check, we'll try to through compile. Okay, it's okay. Okay, so close it by. Okay, I'll check later. Right, thank you. Okay, so yeah, you go, yeah. So, yeah, you just take them off before. Off before you pick up, you don't have to check. Just make sure that the code is generally checked for the one. Okay, leave quietly, please. Thank you. Okay. Write your name in English, please, because in case it can't be just good number. I don't want to have to try to do it from Chinese we're off the chairs. Okay, yeah, that's good. Okay, great. Bye-bye. I'm not looking at it. You're going to look at the I should see them all today. Okay. Okay, we're not going to check it. Something like that, but that's actually probably okay. We'll see. We'll check your things. There you go. Okay, bye-bye, John. I will escort you to the door. Bye-bye. Okay, thank you. I should get the table. Well, we only look at the time, but it's running the chest. Okay. It's not running okay. How much time do we have? Got 2 more minutes. Okay, we are now 4:02. Is there another class for me today or not? Are you leaving or not? I'll give you the next version. Okay, okay. So that's okay, this is your code, it's good, radio now. There's a problem. Problem UML. UML is problem. That's problem. UML is wrong. Code is correct, UML is wrong. Think of a way to turn. UML are things you're doing. Is it correct?
It's correct, but you don't know how to run the code.
What?
How to compile.
You got errors, right? Still? Yeah, still errors, right? It's not. Okay, about 3 more minutes, guys. Okay. Okay. Next time, I'll go for last one. I will go to this class. Okay. Is it running? Let's go. What was the problem? Right. Either or is okay. But you can't do both. Whereas you'll know only what you're doing, not how you're doing. You understand what I mean? When you're doing the function, you don't know what you're doing. You don't know what you're doing, not decide how to do it. Okay? Okay, good. All right, great. What? He could check to see, is it okay? Or has he still got problems? Kenny, does he know how to run the program yet?
Yes.
I know you made a mistake, that's why you're still here. Is it okay?
It's okay.
Oh, yeah. Is the answer the textbook for this question? Oh, okay, that's okay, that's okay, that's okay. I see. When you wrote the answer at the back of the textbook, so he couldn't read his own notes. You have 3 more milestones, only 1 milestone just to pass. That's bare minimum. Come on. Sheesh. No minimize. Come on. Yeah. finished. Okay. Let's collect milestone 4. Are you milestone 4? Or milestone, okay, you can have someone into milestone 3. We'll collect milestone 4. You can start to collect milestone 4 to 3. If they haven't got milestone 4 by now, they will not likely get. Cannot get. Okay. You're still doing milestone 3, milestone 3. Milestone 3, okay. Milestone 3, milestone 4. Milestone 3, okay. Milestone 4, put down computer. Thank you very much, guys. Okay, so now, we don't return now. Okay, bye-bye. Hello, what are you doing? I think you want to have some today. Okay, I'll take away your one. I guess we should need to probably close out. Okay. So, okay, we'll finish now, but we'll try to show you what's wrong with your code. But test is finished. 考试结束了，可是我们要介绍你的 code 有什么问题。Okay? So, pardon? Yeah, take paper, and we'll try to introduce what's wrong. Okay? Okay, let's start with Jim. See what's happening here. Okay. Okay, we're looking here. I don't know why. First of all, fine. So I would know this is style. So but it's not good. Don't use slope. Use double. You see, we don't have to go anywhere with it. It's something to use. I show you that it's there, but I don't think it's not really mentioned something you should be using. Okay? Flow is used in a specific case. It's used for embedded systems, not regular programs. Okay, it's used for an embedded system, special case. Okay, so we try not to like, for example, if you're using it on like a ESP32 microcontroller for a refrigerator, you probably use it because it's got very low power, very low, very cheap chip. Okay, this guy is this way. Okay, so this is your function kernel, right? So what it needs that it needs two doubles. So it's got to say function kernel could return a double. It needs what does it need? It needs double A, and it also needs a double B. So it needs two doubles, right? Or two of these floating point doubles. Okay, so this is basic double. It requires two floating point doubles to return a floating point double. Now, integer main, what does it get from the operating system? Does it get anything from the operating system? No, it doesn't. I'm here, so this should be void. So have a void here to say it doesn't get anything from the operating system. And we'll start any program. We have it. Okay, this is correct. Double A, double B, and double C, A, number A, correct. This can do okay. This can do okay. This can do this part okay, except I don't know what you got. You don't need the brackets. You're giving it the value in A, the value in B, and you're returning what it into the calculator. Putting in C2. No, you declare it as C. This is C, right? C2 you declare it, okay? same state, and all the semicolons, this, okay, and it's better to do it this way, double, the equal, a times a plus b equal. Some number that would be a complete code, okay? Now, we'll put it there, 3 fingers. So we'll put it in A, scanning for A, scanning for B, scanning for C, then we're counting on 5 minutes. Okay, and then the printer should be okay. 0.2, these are both going to be L. Match the factory. Okay, so that should be okay. All right, that will be correct. Okay, so to look at the example, try to work through and understand the 3 examples. Going through it, you just need to know up the variables. This one's only up to the variables, right? So yeah, so make sure you study all the examples online. With our page walk to the PowerPoints, and make sure you see that each of them are basically very similar style. But your style is totally different from all the teaching class. Okay? And I don't think it's good style. But it's acceptable. This is acceptable, it's not good. But it's just, understand what I mean? It's bare level acceptable. But I would think it would be better to try to do it do it like 100% code, not 60% code. It's just enough to get by the milestone. Okay. Okay, you're welcome. Okay.
Okay.
Okay. Okay. Okay, that's good. So, the crucial thing, the main mistake, this should be not 4, it should be double. Because you want to give back what you got from double. And double. Okay, and then C. Okay. So what it's doing is print F and so X is going to go up under here. The one. C is double. That's what I'm going to do. Okay. So the division. C equals. Okay, so we come down here. This equal has these 2 functions, right? Split, double out. It's here, there's a function right there. That's a function for that. Now you can add the entry to this. Good. I calculate the hypotenuse. Calculates the squares. Puts in the container C, and then takes the value of 2. And put it back in this equation. And then I print that. So as the code runs, this is what happens. So that's what we start with. Okay, I've got all the ones. Everybody, let's look at these folks. Well, the main core I've got main as a A, B, and C, and the N and sub would be C now, right? I have C, right? And also another, I have also A, B, C. Okay, so now you would take A and B and give these two numbers and give a copy to the subroutine 3, right? And then I'm going to calculate 3 squared plus 3 squared. 9 plus 9 is 18. I calculate 18, right? Right, 18, right? 3 squared. Okay, so what happens? Go where it comes, all that positives. It gives it 3 and 3. This is the calculation. Then it replaces when the return actually is, when return is replacing all this with 18. Okay, and then it puts 18 in C. And then here I put in the value C is 18. Okay. So another way you can do this if you want to shorten it. You don't want to do C or C. Okay, so what it's now doing is it's taking the value of A and B, setting it in this place, doing the calculation, bringing it back here, and putting it in here. You don't need to. Okay, this is basically, so it basically, we're having first of all to account, we're starting from the inside, starts from the inside out, it does this calculation, gets the number, and then takes that number and says, okay, okay? Any more questions? Can I ask you a question, Paul? Paul, right? Good, okay, good, okay. Make sure you're correct. But the main thing is this idea of increasing the return value. So when you want to do a calculation, you try to return the same with the calculation. Okay, when do we use void? You might want to use void if you are trying to return it. Yeah, then you're using pointer. Like, okay, how can I do this before? How do I do void this way? A, B, and double. Okay, I'm going to be careful. Okay. So now I have A, B, C, and when I call this function, I give it A, I give it B, that. Okay. C, so now I just say C equals this. I go to the third anymore. Now void. And you want to return anything. You want that to return it. So return anything. So in other words, let's see this time of day, here's the value of A, here's the value of B, and here's the added one. Okay? But this is how you should not be quoting. Before you guys do not quote. Using void, do it very well. No, you want to make it much more clear for somebody. Because then you look at the data C, rather than doing this, but it's the hardest. Okay, great, okay. We gotta get out, okay.
Okay. I gotta get this thing.
They're quite upset with my poop.